Hello everyone and welcome to the video from Math 8 Lesson 7. This lesson has to do with Chapter 6 Section 2 that is found on page 224 in the book. And this section has to do with percent of change. So we're still in the chapter that has to do with percentages, so percents. And one of the things you need to know how to do with percents is find the percent of change of something, okay? So the first thing we're going to do is we're going to look at the definition for percent of change. So the definition of percent of change is the percent that a quantity changes from the original amount. Okay, so notice in all caps here, original amount in all capital letters here. Okay, that means it's pretty important that we know what the original amount is. But I want to focus for a second on this word quantity. The percent that a quantity changes from an original amount. Okay, so when we're talking about a quantity, we're actually talking about pretty much anything. Okay, as you'll see in the examples, we're going to be talking about hours spent online. Okay, another quantity we could have is number of home runs. Okay, we could have number of books. Okay, amount of time spent cleaning, amount of time spent playing video games. Pretty much anything you can count or anything you can find a quantity of, we can talk about it in terms of percent of change. Okay, the only difference is instead of saying how much something changes just by, once again, how much it changes, we're going to be talking about it in terms of percent. So by what percent did something change? Okay, so once again, percent of what? Well, it's percent that a quantity changes from the original amount. So we're going to be taking a percent of the original amount, whatever the amount is that we're talking about, okay? So this section, we do have a formula, and the formula that we do want to use, and this is going to be used for every single question in this section, okay? Percent of change is equal to, okay, the amount of change there is. So the amount of change in whatever it is you're talking about divided by, which that's a pretty crappy division symbol, divided by the original amount. And that's why the term original amount is in caps up here, because it's very important we know what the original amount is that we're starting with, okay? Now, in terms of what that amount's going to be, it should be very clear from the question you're being asked, but if you pay attention during the examples that I go over here, finding the original amount's actually really easy, okay? But the last thing before we jump into some examples that I want to say is, well, we can have changes. Well, if something changes, so a number changes, it can either go up or go down, okay? Or technically stay the same, as you'll see in at least a couple of the questions on the practice and the homework, okay? But in that case, we can either have a number go up or go down, okay? Meaning we can either have a number increase or decrease. So in that same idea there, you can have percent. So you can have A, I guess, which let me. So you can have a percent increase. So you can have something, a number or a quantity that increases. So you can have a percent increase or a percent decrease. Okay. And that last part right there, that's actually another easy thing to tell, okay? If your number goes up, it's going to be an increase. If your number goes down, it's going to be a decrease, okay? So how we talk about increase and decrease from before, okay? Increase means your number gets bigger or gets larger, and decrease means your number decreases, so it gets smaller or gets gets smaller, okay? So let's go ahead and look at some examples. So example 1, this is the same as example 1 in the book. In this example, they tell you you're going to be finding a percent increase. So the table shows the number of hours you spent online last weekend. So here's the question. So that was important to know the context of the question. But the real question that's being asked here is, what is the percent change in your online time from Saturday to Sunday? Okay, and this last little part right here, from Saturday to Sunday, that's actually very important when it comes to figuring out what this question's asking, okay? So first off, we see the words percent change or percent increase or percent decrease. As soon as we see any of those phrases, we need to think, okay? We need the percent change formula, okay? So we're going to say percent, and I'm going to abbreviate it and make it smaller here a little bit. So instead of saying percent of change, I'm just going to say percent change is equal to change over original. So I'm kind of abbreviating here to make it easier to remember, okay? But we have percent change is equal to change over original, okay? So that's as soon as we see the words percent change or percent increase or percent decrease. This is the formula we need to use, okay? Now that we have that formula or that we have that equation, we can plug into the equation what we know, okay? Well, we're looking for the percent change, but we can then say, well, what is the change? Well, if we look at our table, okay, got to be able to read a table here. So in this case, they're telling you the day is Saturday. You were online for 2 hours on Saturday. On Sunday, you were online for 4.5 or 4.5 hours. So the question is, okay, what is the percent change from Saturday to Sunday? So in this case, we got to look, well, how much did the number change from Saturday to Sunday? Well, it went from 2 to 4.5. Okay, so 2 to 4.5. Well, that tells us that the change is actually 2.5. Okay, so the change is 2.5. And how I got that is I took 4.5 minus 2, and I got that the number changed by 2.5. Okay, so that's the change. That's how you find the change. And you'll see that that's the same way we do it every single time as we go down through here, okay? The number changed from 2 to 4.5, so that means it changed by 2.5, okay? Now, the only other thing that we need is we need to know what the original number is, or the original amount. Well, the original amount of hours comes from Saturday, because we're going from Saturday to Sunday. So that means on Saturday we had 2. So we are starting, our original amount is 2, okay? And then Sunday, our final amount is 4.5. So in this case, 2 is our original. So if the number changed by 2.5 and the original amount is 2, well, if we do that division, 2.5 divided by 2, we're going to get a decimal. Okay, in this case, we get the decimal 1.25. Once again, 2.5 divided by 2, if you need to double check that in your calculator, 2.5 divided by 2 is 1.25. But we've got to remember what we're even talking about here. We're talking about a percent. So when we get this decimal at the end, and this happens every single time, okay, we need to change this decimal into a percentage. Well, how do we change 1.25 into a percentage? Well, we take the decimal place and we move it 2 places to the right. So what we've got here is we're moving the decimal between the 1 and the 2 to after the 5. That gives us a percentage of 125%. But here's the thing, we're not quite done yet, okay? We know the amount of hours changed by 125%, but here's where that last part of the last slide comes in. We want to know, is this an increase or a decrease? And if you tell by the title of the example here, it's actually going to be an increase. But how can we tell it's an increase? Well, our number went from 2 to 4.5, okay? It got bigger. The number went from 2 to 4.5. That means it increased by 2.5. So that means this is 125% increase, okay? And that's actually our final answer. So what we've got here is we have a number, okay, starting off at 2, and we're saying that number increased by 125% to get to 4.5, okay? So once again, we're saying how much of a percent that it changed. And the 125% kind of makes sense here, right? Because one thing that we know is if we increase something by 100%, okay, if we increase something by 100%, we're effectively doubling it. Well, if we increase 2 by 100%, that means we would be at 4, okay? Well, we're at 4.5, so we increased it by 100% plus a little more, so plus 25%. So we went 100% plus 25% for a total of 125% increase, okay? And that's what a percent increase tells us. It tells us relative to the original amount how much our number increased. So since our starting number was 2, the number 2 increased by 125% to get to 4.5. Okay? And that's honestly how every single one of our questions in this section works. But let's go ahead and look at example 2. In example 2, you can see the title in this one is the opposite of what we did in the last one. In this case, we're still finding a percent change, but we're finding a percent decrease, okay? So let's look at the question and see what numbers we're going to be using, okay? So the bar graph shows a softball player's home run totals. What was the percent of change from 2012 to 2013, okay? So this bar graph that they give you, once again, we got to be able to read graphs, bar graphs, okay? Later on in the year, we'll be looking at scatter plots and what we call box and whisker plots or box plots, okay? But bar graphs and circle graphs and things like that, those should be things that you should be able to read by now. But in this case, we have this bar graph, and on the vertical axis tells us what year it is, so the years. And then the horizontal axis, okay, so the one down here tells us the home runs, number of home runs. So that means the softball player in 2010 hit 18 home runs. In 2011, they hit 10 home runs. In 2012, they hit 28 home runs. And in 2013, they hit 20 home runs. So in this case, we need to read the last part of the question again. What was the percent of change from 2012 to 2013? So in 2012, so that's the year we're starting with. So from 2012, the player hit 28 home runs. When they got to 2013, they only hit 20 home runs. So once again, we see that percent change up here. Okay, so I kind of didn't do this, but the first thing you probably want to do is write down your formula. Okay, so percent change is equal to change over original. Okay, so once again, we want to look. Well, we're going from 2012 to 2013, so that means we're going from 28 to 20. So how much does that number change? Well, it changes by 8. Because once again, if we do 28 minus 20, that gives us the number changed by 8. Over, well, what's the original amount? In this case, we're going from 2012 to 2013. Once again, that word from kind of gives us a hint here. Since we're going from 2012 to 2013, the original amount we actually have is 28. So we're starting with 28 as our original amount, okay? Well, this one's a little bit tricky, but if you plug that into a calculator, you get roughly, and that's the thing in the book, they use this too. So let's use it here. They use a little squiggly equal signs, okay, which means approximately. So we're going to be approximating, or we're going to be estimating here. Basically, we do this when we're rounding. And if you look this up in the calculator, you get that this is 0.28571, I believe. Okay. But what we're going to do, and this is general practice, is if we have a long decimal like that, we usually round it to the nearest thousandths. So in this case, when we're dealing with percents, we're going to round this to 0.286. Okay. But once again, we're dealing with a percent here. So if we have this is roughly our percent, once again, I rounded. So this was actually 2.8571, yada, yada, yada. Okay. It goes on forever. But in this case, I rounded it to 2.86. Well, that's going to be 28.6%. Once again, we move the decimal place 2 places to the left or to the right. Okay. So 2 places to the right gives us 28.6%. But then once again, we're not quite done. We know it's a change of 28.6%, but is it an increase or a decrease? And since our number went from 28 to 20, it went from a bigger number to a smaller number. This is going to be a decrease. Okay. Now don't get messed up and don't get upset when you got decimals like this. Okay, that's something actually in real world applications, hardly anything it works out to be nice numbers like the last example. Most of our fractions and most of our real world applications, they're going to come out to be these nasty decimals like this that we have to know how to deal with. And like I said, most of the time we usually round to the nearest thousandth place. Okay, so that's the 6 right here. So actually it was a 5, but we rounded up to a 6. So that means when we round the percentage, it's actually going to be 28.6%. Okay. And once again, that's why we use the little squiggly lines here to say it's about that. It's not exactly that because we had to round. Okay. But 28.6% decrease. And once again, kind of makes sense. 28.6%. You can kind of think, well, that's close to 25%. Well, if we decrease 28 by 25%, we would be decreasing it to 21 because we'd be decreasing it by 7. Okay. Well, once again, that's kind of close to 25% decrease. So that makes sense. Okay. So I do want to give you 2 more examples, and these are examples that are not found in the book. Okay. So if you've made it this far in the video, or if you remember this from class, these are examples that are not in the book. Okay. So these are ones that are specifically only here or you only saw in class. So extra example number 1. Find the percent of change from 20 days to 12 days. Well, in this case, we're not given any context to tell us what these 20 days and 12 days mean. Okay. We can make up context. So we can say, okay, last year it rained 20 days, or last month it rained 20 days out of the month. This month it rained 12 days. So in this case, what is the percent of change from how many days it rained last month to this month? Okay. But in this case, we don't have that backstory to tell us what this is about. So we're just told we have 20 days and we're going to 12 days, whatever the situation is. Okay. And these are more like the questions you'll see on the practice and the homework. Okay. Now, I will give you some like before where you maybe have to read a graph or understand the context to see where these numbers come from. But in this case, we're told we're going from 20 days to 12 days. So once again, we see this percent of change or percent change. So we know we're going to be using this formula. Okay, so same thing we've used every time. Percent change is equal to change over original. So when we plug in, how much does our number change? Well, it goes from 20 to 12. So much like the last example there, we're going from 20 to 12. If you do 20 minus 12, we get 8. Okay. Once again, where I get this 8, 20 minus 12 is equal to 8. That tells us what we're getting for the change, the number changed by 8. Okay. Over, well, in this case, the original amount, we're going from 20. So that means the original amount is actually 20. From 20 to 12. So that means the original amount's 20. And if we do 8 divided by 20, Once again, if you need to, plug that into your calculator just to double check yourself. But 8 divided by 20 gives us 0.4. Okay, so 0.4. Now this one's a little bit tricky, okay? Once again, we're dealing with a percentage, so 0.4 as a percentage. Well, if we need to move the decimal place 2 places to the right. Well, if we move the decimal there, we've got to fill in this with a 0. So technically we have 0.40, and we know that as 40%. Okay? So we have a 40% change. Well, once again, our last thing we got to do is, was it an increase or was it a decrease? Well, we went from 20 to 12. So we went from a bigger number to a smaller number. So this is actually a 40% decrease. So once again, 40% decrease. That means we decreased the number 20 by 40% to get to 12. Okay, so we decreased by 40%. That means we decreased by 8 because 8 is 40% of 20. Okay, so kind of flashing back to what we did in the last section there. Okay, but a 40% decrease. Now the last example here. Okay, once again, another extra example that is not found in the book. So if you want extra practice, this is the only place you'll find it, whether here or in the in class. I went over this in class as well. But in this case, extra example number 2. Find the percent of change from 40 hours to 50 hours. Well, once again, we see percent of change. We automatically know we need this formula. Percent change is equal to change over original. And once again, it's the same formula every single time with percent change. Percent change is equal to change over original. So now when we plug in the change, well, we went from 40 to 50. Once again, hours here, we don't know the context, but we do know that we're talking about hours. So it could be hours you worked last week versus hours you worked this week, okay? Or it could be number of hours spent studying last month versus number of hours you spent studying this month, okay? Once again, all we know is we're talking about hours and we're going from 40 to 50, okay? So going from 40 to 50, where we get the change is we do 50 minus 40 is equal to 10. Well, that tells us what our change is. Our change is 10. We changed the amount by 10, okay? In this case, the original, well, we're going from 40 to 50, so we started off with 40 hours. So 40 is actually our original amount we're talking about. Well, once again, we do our little calculation here, 10 divided by 40. This one should be a pretty easy one. A lot of you should be able to maybe do that in your head, but if not, once again, 10 divided by 40, you plug that in your calculator, you get 0.25. Well, once again, we got to remember we're talking about a percent here. So since we get this 0.25, this is actually, once again, move the decimal 2 places over, it will be 25%. And once again, the last question we need to answer with these types of questions, if it doesn't tell us in the actual question, okay, we need to say, is this an increase or a decrease? Well, we went from 40 to 50, so our number went from a smaller number to a bigger number. So this is a 25% increase. So what this is saying is when we went from 40 to 50, that's an increase of 25%. So we took 40, we took 25% of it, and we added it to it, okay, because we increased by 10, and 10 is 25% of 40, okay? And once again, kind of makes sense here. 25% increase, well, we went from 40 to 50. If we increased it by 50%, we would be going from 40 to 60. So in this case, it's kind of split the difference there. Half of 50 is 25%. So it makes sense that we increase by 10 hours, okay? So with that being said, this is pretty much all you need to go through the practice and the homework for this section. I have already starred this section on IXL, so if you wanted to get some practice on IXL before you attempt to do the actual graded practice and homework for this section, do make sure you log in and do that. But if you have otherwise, if you have any questions, please let me know, and thank you for watching.